On behalf of Logistics and Supply Chain Innovation Alliance of GBA, I'd like to introduce Professor Chen. Professor Hing Chen is a professor of operations management at the Nottingham University Business School, China. He received MSc degree and a PhD degree from Department of Industry and Manufacturing Systems Engineering, University of Hong Kong. He also earned ENG degree in electrical and electronics engineering from the University of Hong Kong and a BSc degree in economics and management from the London School of Economics and Political Science. Professor Chen has published over 100 peer-reviewed academic articles and edited several special issues for reputable international journals. His publications appear in Production and Operations Management, European Journal of Operational Research, various IEEE transactions, Decision Support Systems, International Journal of Production Economics, International Journal of Production Research, among others. He has been the co-editor of Industry Management and Data Systems since 2014 and has been an associate editor of Transportation Research Part E, Logistics and Transportation Review since 2018. He was an associate editor of the IEEE transactions on industrial electronics from 2009 to 2015, and associate editor of IEEE transactions on industrial informatics from 2014 to 2017. In 2019, Ningbo Municipal Commerce Bureau appointed him as the expert committee member of the Supply Chain Innovation and Application Committee. Now, Professor Chen will give us a seminar talk, and the topic is an authentication platform based on the patented 3D printing, digital watermarking technology, and blockchain technology. Okay, so welcome, Professor Chen.
Okay, thank you, Professor Tan.
Yeah, thank you, Professor Tan, for the nice introduction. And Professor Chen, the stage is yours. Thank you so much.
Okay, thank you. Thank you, Professor Tan, for your introduction. I'm now sharing the PPT. So just to check if you can see the PPT.
Yes.
Yes, okay. Thanks again, Professor Tan, for your introduction, and also Wei, Professor Zhong, for hosting and organizing this seminar. Actually, it's really my real pleasure to go back to my alma mater. As Professor Tan introduced, I got my MSc and PhD actually from the Department of Industrial and Manufacturing System Engineering. So it's like go back home, although virtually now, all right? And hopefully I can do my presentation and visit my home, okay, in the future when traveling is more feasible. Today, I will share a series of my research. Okay, so this topic or this presentation actually is not pinpoint to a particular technical work. So I will focus more on the overall project, okay, rather than some technical aspect. Of course, I will still present some technical background of the various studies, okay, that I will be presenting. So as Professor Tan mentioned, I'm currently a professor in Nottingham University Business School, although as I mentioned, my background is in industrial engineering. My research is still very much on industrial engineering, although in tailored to business context, okay. Currently, I'm also the Associate Dean for Education and Student Experience in business school here. So that's why before the seminar, I mentioned about like the graduation ceremony. So it's quite busy today for me actually. But it's still very happy to present this seminar and share my research with you. Now, so this is the main outline of my presentation today. I will briefly introduce the topic. Actually, as I mentioned, is a summary of a bigger project, okay, which consists of currently 3 phases. So I will go through these 3 phases later on. I'm not going to discuss this here in more detail. and then of course to conclude the presentation. Well, and then I will talk about the journal. I'm now co-editing Industrial Management and Data System. This is an SCI journal. So more details will be provided to you later. Okay, so basically that is the outline. Well, as I've said, this is a series of projects spent over a couple of years. So basically today I'm going to summarize what our project team has been doing over the last few years. And in the phase one, this is a UK funded project. We have various research council in UK, and particularly this one is sponsored by Arts and Humanities Research Council. So this is a joint UK-China project, and my UK counterpart, UK PI is Dr. James Griffin from University of Exeter, and myself is the China PI, if you like, because this is a joint project kind of. The project also consists of a number of other team members from Sussex, Essex, and Dr. Anita Jones, actually originally from Durham. Okay, now this year she moved to Essex. And in phase two of this project, it consists of, again, Dr. Griffin and myself, my engineering colleague in University of Nottingham, Ningbo, China, that time, Dr. Hunong Chu. He's now, he has moved to Taylor's University in Malaysia, and then PhD student, okay, Jerry. So basically phase two is about the patent technology in the title. All right, and then we are now doing this phase three project. Basically is to develop the authentication platform, as the title suggests. Again, this is a collaboration between Nottingham Ningbo University and a number of UK university. And this project, sorry, again, is funded by another AHRC project. If you can remember, phase one is sponsored by one AHRC project, and this is from another one. Also, this is sponsored by another funding in China affiliate to our university, which is called Li Da-sum Innovation Fellowship. Li Da-sum is a famous Hong Kong tycoon, okay? So he actually is a linguist, so he donate some money to the university, and that make the project successful, okay, possible. And again, we have Dr. James Griffin as the project team member and co-I of this Li Da-sum Innovation Fellowship, and he is the PI of the AHRC project. And myself, on the other hand, is the PI of the Li Da-sum Innovation Fellowship. We also have our team member from University of Nottingham, UK, University of Essex, and also some other colleagues in our Ningbo China campus, plus other project team member. Mainly they are PhD students under our supervision. So basically, this is just to introduce the team member for the different phases of our study. Now, this is the background of this study. It's all about 3D printing industry. Well, although I understand that the audience, you may come from industrial engineering domain, but today I'm not going to talk about the 3D printing technology itself. Okay? It's more about the development and application of 3D printing in the industry, right? How 3D printing can diffuse to the industry, and why the diffusion rate or penetration is still not so satisfactory. But in fact, you can see, particularly in Chinese context, because our projects are basically focused on China 3D printing industry. You can see on the left-hand side, the development and expansion of the industry is quite healthy. Okay, I would say. But in particular, we are talking about the 3D printing surface here, which is the focus of this project. Okay. Is also expanding very quickly, and actually in terms of percentage, the 3D printing surface application actually outperform other areas. And on the right hand side, you can also see this is the application area of our industry, which consists of a number of industrial sector, etc. Okay, put it in short, the 3D printing industry is still growing, and we need to find some way to promote it again and make it even more healthy in the future. The problem here is that we have identified one difficulties in terms of IPR protection, intellectual property rights protection here. Well, IPR itself, okay, regardless of 3D printing or involved digital data, is difficult enough. Okay, it's time consuming to protect IP and difficult to realize the cost. Okay, we invest for IPR protection. It's very difficult to do, for example, ROI analysis. It's very difficult to visualize the benefit we can gain from the investment. So many companies, they just ignore this part, or underestimate the importance of this application area. And of course, protecting IPR is also in terms of efficiency is very low, and that also means the cost is very high. And this is one attribute to the previous bullet point I mentioned. It's difficult to realize the profit. And when we shift the focus to digital data, for example, we talk about 3D printing here today. They are even more difficult because the amount of data, the volume of data we are handling, the nature of the data, because we are doing real-time data collection. So a large amount of data are available on a real-time basis. And this kind of digital data, normally they are generated by what we call digital device or digital manufacturing technology, where again, 3D printing is an example. So a couple of these, that means we are now talking about digital assets, intangible data, rather than physical objects. So this adds another layer of difficulty to IPR protection. And of course, because of the nature, digital nature of this data, it's very easy to be changed, to be damaged and lost, etc. Okay, and of course, there's a need to intensify. There's a need to understand the intensified difficulties in IPR protection because of the 3DP characteristic. For example, the internet, which is open. Okay. Especially when we talk about 3D printing, it may involve open source software to handle the file, something I will discuss more later if you don't know what 3DP is about. Okay, the capability offered by the 3DP, the ownership, etc. So the ownership of the design, of course, I meant. So there are additional characteristics, that make IPR protection even more difficult. And there is a lack of standard in the 3DP industry regarding this area. So that's why there is a need to pay more attention on IPR protection regarding 3DP applications. Well, you can see here some news, although this is in Chinese, but this is just an example. There are lots of government initiative to improve this area, and some news in the Western country as well. Okay, that link 3D printing to IP law, and how to protect 3D printing copyright issues, and lots of these news you can come across in the industry. So that also means there is a pressing need to consider IPR protection in this 3D printing area. Now, go to the phase 1 study. I'm not going to talk about like research methodology, literature review, etc. Because as I've said, I'm not focusing on just say one study here. But yet, when we go back to the phase 1 study a couple of years ago, we first tried to understand the industrial needs. So that's why we conducted semi-structured interviews with manufacturing companies, mainly manufacturing companies in Ningbo, Shanghai, Hangzhou, Guangzhou, Shenzhen. You can see they are probably the most manufacturing intensive cities in China, mainland China. They represent, they are quite good representation of the companies, okay, in the 3D printing industry. The mix of the company include like government department, cloud computing service provider, the real manufacturer. That means they really do 3D printing manufacturing, equipment provider, and also a platform provider. And of course, apart from the legal issues, insights from our interview is that the use of 3D printing is very important. It is beneficial to this company in the R&D and design stage. Well, mainly because the nature of 3D printing is free from tooling. So the design cost actually can be lower. And also because of the nature of the 3D printing and mass customization is possible. So this is highly related to how we configure our manufacturing and supply chain processes. But there is some problem in this regard as well, because from our interviews, we found that 3D printing is not, the penetration rate of 3D printing is not as high as we expect. One reason is because many manufacturers or many companies, they just make use of 3D printing as a substitute technology, okay, to their existing manufacturing process. So this substitution actually is not quite ideal, okay, in terms of applying or fully utilize the 3D printing characteristic. But this is somehow out of the scope of today's presentation. So I'm not going to discuss this in more detail, but that actually led to another branch of my research regarding this type of Industry 4.0 manufacturing technology adoption. 3D printing also create lots of data, simply because of the digital file nature and the ease of changing the design during the design stage. That also means we can create lots of digital file, and there's a need to improve data management as well. And this is also one of the barriers in this 3D printing adoption. And go back to our focus, of course, from the interview, we also identify a number of potential issues, mainly regarding the matching between current IP law and the use of 3D printing technology. And this gap actually creates some potential illegal usage activities. It's because the digital content of 3D printing, of course, when I talk about 3D printing here, is involve digital content, and likewise other digital manufacturing also involve digital content. So the interviews or the result here, the insights here actually is also applicable to other type of digital manufacturing techniques. This type of manufacturing techniques actually is very easy to for others people to get hold of the digital content without permission. And if something is shared without permission, that means this is an illegal activity. And of course, this will dilute the brand image of the original, designer very seriously. And it's very difficult to detect this infringement. And I will elaborate this in more detail later. But the main reason here is because of the digital nature. And if we don't protect the digital file or, the 3D printed objects well, it's very difficult to detect this infringement. That means it's very difficult for us to identify, find out the source, okay, of leakage, and then who are infringing our IP ownership. And of course, that also means it's very difficult for company to check for this counterfeiting and tracing purpose. As I mentioned before, there is also a lack of IP standard and regulation in the industry. Time-consuming, high cost to protect IPR, as I mentioned earlier, conflicts between innovation and business opportunity. And also there is what we call a hysteresis of law. Well, hysteresis is an engineering concept, I think, okay? Engineers are very familiar with this. So when innovation or, a new technology is being developed, normally it will create certain gap in the existing legal framework. So that means the legal frameworks almost always lag behind technological innovation. And this is what we call hysteresis. So that this is a kind of intrinsic lag, okay, in terms of regulation to protect new technology. So that is also one of the reasons why protecting 3D printing IPR is very difficult. Of course, that also means we need to make use of various existing IP legal framework to protect our 3D content. And that will make the consideration very complicated because there's no single unified standard to protect 3D printing objects. And whenever we need to link or make use of several legal frameworks or several regulations, then the complexity is, of course, come along. I think I don't need to repeat this. Basically, this is also about the IPR issues regarding the 3D printing application. But at the end, the main conclusion here, or the main highlight, is the fourth bullet point. 10 to 20% of these interviewees were already interested in watermarking technology, okay? Particularly in high-value products, for example, medical devices. So this first phase of the study actually has been published in IJPE, International Journal of Production Economics, and also all the proceeding regarding the interviews, etc., is published in a book on the right-hand side. So if you're interested in that, you can book further. Then from the first phase of study, as I mentioned, because watermarking is a potential technique, okay, to protect 3D printing content. Well, before I talk about how to apply watermarking to 3D content, of course, let's talk about watermarking. Well, everyone knows watermark. You can find it in a bank notes, etc. So this is mainly to protect the authenticity of this bank note, right? So you can see this here. But in terms of, well, you can see this is a physical one. But in terms of digital watermark, which is the focus of our technology, well, this is something in digital form. And 10 years ago, roughly like 10 years ago, there is a online puzzle or competition, if you like. Someone actually posts this image on the internet. And you can see actually the message is that, hello again, I'll search for intelligent individuals, okay? The first clue you can see is hidden within this image. So can you see anything from this image? Give you 5 seconds. Nothing, right? So basically there is a code there, 3301. Is there anything in relation to this? Well, 10 years ago when this image was posted in some forum, okay, on the internet, many people, especially computer scientists, they spend a lot of time to investigate this, how to decode, okay, so-called the image or the clue within this image. Well, one technique many people use is to increase the brightness or intensity of this image so that, oops, actually you can see an image, something like that behind the scene. Well, but there's nothing new, okay, about the message. And someone else, okay, many people also try to decode the image. And some more intelligent people, actually, they make use of the text file. Well, shall I say text file? They open this, retrieve this image as a text file, okay? And then, of course, that will come along a series of strings like this. And actually, there are lots of message or lots of letters hidden behind, okay? The black image. You can see a lot of black colors here. And actually, a lot of text are embedded in the black color. So when you try to do some, well, play around this text, actually, you can find something like a web address. And if you point to the web address, basically, the web address will point you to a physical location. And that physical location, you can find something similar to this diagram, which is a cicada, okay? But the story actually hasn't stopped, to be honest. So this is the first phase or first 2 phases of this online competition or online puzzle. Nobody knows what happened afterwards. And they actually, the owner of this image, they post another puzzle, and up to now, no one knows what exactly the result is about. But this example nicely demonstrates what digital marking is about. So we can hide something like here. You cannot see it, right? So this is basically, well, almost invisible to you. But actually, technically, there are lots of things inside or behind the screen. And this message behind the scene actually is the watermark we talk about, and in digital form. But this example also shows you very nicely how we want to apply the watermarking concept, okay, which is of course very basic, but in 3D content, okay. And lots of now go back to the theoretical part. Actually, lots of papers particularly in those attribute transactions talk about this. And like here, this is some example which change the surface of some physical objects and then try to hide the watermark, okay, embedded with this object. So the watermark is physically found on the object itself. And of course, we did some techniques to process this and then get the watermark back from it. And this is exactly the concept of our pattern watermarking techniques. I'm not going to talk about this as I mentioned. I won't do a literature review on this part here again. Now go back to the 3D printing application. If you can remember the example I just quote, okay, about the cicada image. So 3D printing basically fit in that concept very well. So when we want to print a 3D object, okay, make use of the 3D printing technology. Just in case you don't know what 3D printing is about, we need to develop a what we call STL file from a CAD or CAM software. And then we convert this digital file through some transfer software and then download it to the 3D printer. And then we make use of the 3D printing technology, which is laser-based, of course, okay? And then print the objects here, which is a mug or a cup here, all right? So at the end, we got a physical object. Now, if we go to the ST file here, of course, we can add the watermark in the STL file. But if we add the watermark within the STL file, someone can get it, get the STL file, watermark STL file. They are still able to print, okay, the cup here without any permission. So it's also very difficult to trace the origin of this leakage. So a better approach to add the watermark actually is to put the watermark in the physical product, embed with the physical product, which is step 8 here, rather than in the digital form. Now, one reason is we cannot do this is because the watermark here, if we add it to the STL file, is static in nature. Well, in many other applications, which is physical output in nature, like YouTube, okay, when you view a video, actually, YouTube adds some watermark to the video as well. So they know when you download the video and they can trace, okay, if you make use of the video for commercial purpose. Because of the technical output nature, all right, we are able to add a dynamic watermark into the digital content, which is the output. But however, on this occasion, when we talk about 3D printing application, we are unable to add a dynamic watermark if we make use of the watermark, if we add the watermark in the digital file here alone. So basically, let's go back to this whole encryption and description process. So if we want to add a watermark here, we can, of course, add the information, embed it with the STL file. But whenever the file is attacked, okay, we need to extract the watermark. And if we add the watermark in the digital file, we are unable to extract, okay, the digital content in that regard in terms of protection. So that's why we want to attach the watermark in the physical object, so that whenever we extract the watermark here at the end on the right-hand side, we can recover the 3D model and extract the watermark, which is tailor-made to different, for example, customer or different batch of production. And based on this concept, we developed a watermarking technique, okay, which is patterned, okay, 2 years ago, perhaps. I can't remember exactly. Yes, it should be 2 years ago. But we developed this a couple of years back, okay, initially. So the basic principle is that when we do the watermarking, when we add the watermarking here, we make small change to the model physically, and that will not affect the overall, say, function, feature, outlook of the model itself. And this change are recorded as a key, okay, and is owned by the designer. So the designer is able to make use of this key and make changes accordingly and disseminate to different well, customer or manufacturer. And in theory, this can be made on an item level as well, because one of the benefit or one of the advantages of 3D printing is that we can we can do production at an item equal to one single unit level. All right. So in theory, we can make changes, this kind of small changes on individual item. But whether or not there is such a lead is another issue. Okay. But the concept itself is able to be applied to item level. Okay. So through this watermarking procedure, designer, of course, they can introduce different keys assigned to different customer. So whenever a printed object is found illegally produced, then the designer or the platform service provider, etc., can trace which lot of production is problematic, and that's also mean which at least the source of leakage can be identified. And basically, this is about the technical background of the watermarking technique. Okay, what we do is that we introduce the coordinates of the 3D printing model. Okay, and then we extract the coordinate, the global coordinate of the 3D product. Okay, and store it in the database kind of. And then when we after we print a product, basically we're able to extract the watermark in the 3D model. And how we determine the watermark, basically we make use of an algorithm, transform the coordinate to some other coordinate. And then watermark is embedded based on those coordinates. So in other words, basically we have a set of coordinates which are related to the watermark. And then this watermark is kind of moving around, okay, if you like. Basically that is the transformation we talk about mathematically. So this difference basically can be calculated, and then we can plot the differences as a variance graph, which is unique for a specific pair of the original and watermark digital model. Of course, it's also this is also unique between watermark digital model 1 and watermark digital model 2, etc. So that's why, as I mentioned, basically this concept can be applied at item level. Well, of course, it's a matter of list whether we need to do it at the item level. And the issue here is that when the 3D printing design is produced, manufactured, the watermark will stay with the physical objects. So we can always find the watermark on the physical item rather than in the digital file alone. Okay. So in terms of the algorithm, basically this is a flow that illustrate the watermarking technique. And basically, I'm not going to discuss this further, but this summarizes what I have just said. And mathematically, this is a more technical representation of that algorithm. So you can see we basically modify the CAD file, CAD models based on various coordinates, and then we can extract the location of the watermark after scanning. Okay. Well, basically, this is very technical. I'm not going to discuss this in detail, but this is how we determine the coordinates. This is the procedure. We calculate the coefficient, etc. So basically, at the end, we will form a matrix like this. So M0 or MO is the original model with a set of coordinates. M1 is one variance, and you can see the set of coordinates have been changed. And also, you can see even within one matrix, we have a number of variants here. And M2 is another variation, okay? And M3, M4, they represent other models. So basically, based on this coordinates, we can understand, okay, where the watermark is put. And actually, this also can accommodate different types, different shape of watermark on the surface. So because of that, we are able to calculate what I meant the variance graph, okay, by comparing M0 and M1, M0 and M2, etc. Of course, M1 and M2 also possible. So these are the physical object. M0 is the original one. So physically, you can see no difference between these 5 objects, I would say, right? But in fact, the watermark are embedded on these 5 objects. And the next question to you is, of course, then we have the watermark. How can we identify M1, M2, M3, and M4, okay, which are different from M0? Basically, we need a scanner. So a scanner can retrieve the curvature of each individual model, and then we can get back or retrieve the coordinate and calculate. This is the variance graph I mentioned. So you can see the top left-hand corner, M0 minus M1 is the difference between M0 and M1. Okay, so you can, from the graph, you can see the differences in terms of the curvature, and this is well, kind of the characteristic of the watermark here. And M0 minus M2 below this is the difference between M0 and M2. So basically, this is the idea of the watermark. And on the right-hand side of this diagram, basically, they are the scanned version of M1. So we go M11 dash, the scanned version of M2, M22 dash, etc. So again, by comparing M11 dot and M0, we can produce the similar variance graph here. And by comparing these two graphs, well, through certain algorithm, of course, which I'm not going to discuss the technical detail, we can calculate a threshold, okay, or I should say we can calculate an index. So if the index fall below certain threshold, basically we can conclude that they are identical or not, all right? So through this approach, we can identify or we can add the watermark into the physical object, and then we can retrieve the watermark from the physical object and then make the comparison. So the whole concept, I would say, is not too difficult, but the innovation here, the reason why we got the patent for this technique is, of course, about the algorithm, the calculation, the mathematical formulation behind, which I'm not going to discuss further, okay? Now, basically, this is a very quick summary of the phase 2 study of this bigger project. After we have developed the patent technology for watermarking, the next issue come to us is that how we can really use it in the industry. Well, the patent itself is technical in nature. So that means we patent the algorithm in adding the watermarks and retrieving the watermark from the physical object. When we first patent this technology, our initial concept is not to commercialize it per se. We didn't think about application. Well, we want to protect the technology so that we can still continue research based on the algorithm behind. We don't want to someone kind of steal the idea and then they patent the algorithm so that it would make our research difficult. But after we get this algorithm design, the patent technology approved, we thought about how we can apply it in the industry, because this is very important to us. We want to actually create certain impact in the industry, try to promote this technology in the industry. Well, the missing part of the patent is that although the technical background is there, but there is a lack of procedure to really protect and authenticate the IP issues of the 3D printed object. So that's why it's come to us another extension of this research, which is the phase 3 of this study, and this is ongoing. We are now developing a platform. Okay, we call it authentication platform, and that embed the patent watermarking technology and the blockchain concept. So basically, there is a demand for this authentication, okay? Simply because we can find a way to protect IP, but we also need the authentication approach, the procedure to help us execute or implement the protection. So in this project, we are going to develop this platform, which is actually ongoing. We will also collect target user profile and then identify their list in the actual operation so that the platform itself can be kind of commercialized in the industry. By commercialize, we are not really talking about profit gain in commercialization. We want to make use of this technology and the platform we develop later on to help the industry rather than to really do business. We are still academic people, right? The research we are doing here, we want to create impact. This is the main focus. And of course, because of this platform, we would expect that the the 3D printing application can be improved. Now, this is the system framework of the whole platform. So you can see on the left-hand side here is the 3D printing digital model encryption service. So this is highly related to the 3D printed watermarking checklist we mentioned. And we need to create several layers of application, including the web portal that is interface to the external users. And after they have the STL file available, they can upload it to the platform, okay? And then we can do the encryption and description. That means we can produce another digital file for them to sell to their customer. And this is the whole overall schema. And what is missing here that I will be talking about is the authentication service. We need another technology, which is the blockchain type of technology to help us to keep track of the transaction. That means the transaction here is the change of the watermark, or the addition of the watermark during the process. Again, this is another business flow diagram about the whole platform. I'm not going to discuss this in too much detail. This is very technical. Well, another issues come to this is, of course, you may argue, well, why do we need blockchain? Actually, the question here is blockchain technology also copyrightable? Now, of course, if you don't know what blockchain is about, basically this is something our team extract from the internet. So this is the code about the program of blockchain, and you can see, basically all the transaction can be identified here in the program. So if you look at this, basically they are also copyrightable content, okay? And in our 3D printing application, you can see, if you can remember, the watermarking technology or technique basically focus on the coordinates of the watermark and the shape of the watermark, of course, at the end. And this coordinate and shape can be stored, okay, as part of the attribute in one of this what we call block, of course, okay. And by adding this block together, we form the blockchain, and then we can keep tracking different versions of the watermark we offer to different customers. So basically, this blockchain part of the platform help us to record, okay, different version of the watermark per se. So basically, that is a useful tool for us to well, execute our 3D watermarking techniques. And on the literature side, again, we look at both practice and literature, theoretical side. Basically, lots of legal people, law people, they also mention about how we can make use of blockchain, okay, to copyright content. And this help us, of course, to trace the chain of use of watermarks we issue to different 3D printed object, okay, and of course the subsequent changes. Now, you may ask, what are we going to advance based on this platform? So we have already developed the watermarking technology, which is the patent technology, and then we are now going to develop a means to enable the licensing of the content online, which is the platform. So basically, blockchain can help us to restore the evidence of the IPRs. This is something I just mentioned based on the illustration of the program, the code. And actually, some Supreme Court, they also accept and facilitate the blockchain deposition service, and they recognize this as a kind of evidence. Of course, we understand that blockchain is not silver bullet. You cannot do everything. So when we do the design of this platform, basically, we also understand that the application is limited. So this is something in our mind. And if we compare our platform to be developed here, okay, and the traditional printing service platform, basically on the right-hand side, you can see we offer authentication service supported by our patent watermarking technology, the authentications, trading, and storage process for the IPR, etc. And we also can store the data used by the blockchain. So I haven't touched on this data yet, okay? But when we go back, if you can remember when I talk about the phase 1 study, data management is an issue that we identify in the industry. And if we make use of this platform, basically it will help us to store up all the data. Okay, we can connect from the usage with different watermark versions. Okay, and basically this is what we call big data, right? So by analyzing those data indirectly, we can also make use of this data to help, okay, our company, our manufacturers to analyze the usage pattern, etc. But again, you know, this is more or less like a separate issue, so out of the scope of this presentation. And of course, this is also a platform for multiple digital products. We are not just talking about 3D product, okay, 3D printing product. In fact, the concept, as I mentioned earlier, can be applied to various digital manufacturing technology. So once this platform is available, basically we can apply similar concept to other applications. So this is also very useful, well, in the Industry 4.0 era. All right. Now, the platform, the concept here can help us to address a number of bottlenecks. As I mentioned before, there is a lack of integrated 3D printing authentication service platform. Okay, so for digital model property, IPR authentications, trading and storage service, and also commercialization of this 3D printing authentication encryption algorithm, which is the 3D print, the pattern watermarking technology, okay, etc. So we can also make use of the blockchain technology to help IP protection as a mechanism, okay? So that can also link to, for example, cloud blockchain storage, as I mentioned. So a number of bottlenecks that we can address. And at the end, of course, this platform can also help us to advance the industry in a number of areas. For example, as I mentioned before, of course, the authentication platform, okay, and it actually creates an industry ecosystem for this pattern 3D printing watermarking technology. Now, we go back to the concept of product surface system, actually, okay? We are talking about the 3D printing products, which is the product, but the authentication surface itself is surface. So when we combine these two together, basically it is the product surface system. And of course, hopefully we can also provide later on a standard development or standardized process for this 3D printing authentication industry. Go back to the phase 1 study, something I didn't mention. Actually, a lot of manufacturers, they are very willing to pay for example, license, okay, to use protected content. But the problem here is that currently there is a lack of approach. They cannot, they don't know how to do it. They don't know how to pay for the license. So there is no standard or, you know, a authorized way for them to buy, okay, so to buy the license from a copyright owner. So this platform hopefully can create a standardized approach for them, okay, to, well, respect IP protection, all right? So basically, that's almost the end of this phase 3 study, where this platform is ongoing, although we haven't really implemented it yet in the industry. So this also, the concept has also been reported by our local press here. To conclude, basically, the platform we are talking about actually embed a number of technology. The encryption, that means the watermarking technology, the authentication system, and also the trading business system, okay, which is the ecosystem I just mentioned. And at the end, of course, the aim is to promote the protection of IPRs of 3D printed objects and companies. And hopefully this ecosystem can help, okay, penetrate 3D printing in the industry as well. So basically, that's all about the wider project I would like to share with you. And perhaps if time allow, I can talk about IMDS first, all right? Wait, or you want to do the Q&A now?
Yeah, thank you, Professor Chen. I think we can finish all the presentation and come back for the Q&A Q&A at the end.
All right. Okay. So as I mentioned earlier, I will make use of a couple of minutes to introduce the journal I'm co-editing. This is called IMDS, Industrial Manufacturing and Data System. You can see from the name, as this suggests, is a interface between industrial management or operation management or industrial engineering. So we define industrial management quite broadly. And data system, you know, just like the data 3D printing data I mentioned, well, this is of course related to information technology or information system. So we don't use information system here again, you know, that means we accept a wider definition of data system. It's not necessarily a piece of software or information system web application, right? IoT, RFID, they are not kind of information system to me from my engineering training. So they are more like a system to generate data. So this basically is the scope of the journal. This is an SCI index journal, as I mentioned. The 2020 impact factor is 4.2 something. Well, if you know impact factor, 2020 is the latest one, okay? 2021, we have 2020 impact factor. 2022, we will have 2021 impact factor, which should be available somewhere in June normally. And although the impact factor has not been released yet, but you know, we can calculate the impact factor based on Web of Science statistics. Basically, it will be close to 5 in this presentation, next year presentation, 2021 presentation. We also have site score, which is 7.1. This data basically means that IMDS is quite a good journal in this field, okay, compared to our peers. It wants to be a Q1 journal, but last year it's just dropped below Q1, and hopefully it will back to Q1 next year. One feature of IMDS here is that we have quite a fast turnaround time. Normally, the average time from submission to initial decision is 45 days. That includes editorial screening, which normally takes, well, say 1 week or so. So the overall review time is just over 1 month. And if you are lucky enough, then you may be able to get a revision chance, okay? And that will be with you for another month or 6 weeks or so. Then the average time from submission to final acceptance normally is less than 100 days, which means it's just below 3 months. IMDS also indexed in other area like the Australian Business School Dean's List. It is ranked as a journal in the list. Well, we publish about 120 papers a year, and the acceptance rate is about 15%. So you can see that also means we normally receive more than 700, close to 800 submission. You can see over the last few years, the acceptance rate is quite consistent, except year 2020, simply because in that year, you can also see the number of papers we have accepted jumped from roughly about 100 to 120. In 2020, basically, we increased the number of issues from 9 issues to 12 issues because of the number of submission we received in recent year. So of course, that is a rise in the acceptance rate because we increased the number of papers published. But it's dropped last year and it's quite consistent, I would say, in this year's statistic. Go back to the scope. Basically, I'm just focused on the topic, as I mentioned, treating the interface between operation management, industrial management, industrial engineering, and information system, information technology, data system. So we are quite a unique journal because if you look at other journals in the fields, they accept either operation management or information system. But we need our paper to address both. So it must be treating the interface between these two areas. Well, after all, IMOM and IS, they are sister discipline, I would say. Actually, it's very easy to find this interface. Those are the key topics we accept, like big data research, e-business. traditional production planning and control, scheduling, logistic and supply chain management. So they are key topics. But if the scope, like production planning and control, if you submit a paper pure, which is pure OR based, okay, about production planning and control, very likely I will just reject the paper because there is a lack of the information system component. Okay, so you need to satisfy the scope of the journal. And you can also see like our recent special issues, what we want to publish, like smart supply chain management to achieve carbon neutrality, risk, challenges, and opportunity. Smart supply chain management, smart already implicitly mentioned something about data system. Supply chain management, of course, under industrial management. How will Industry 4.0 affect circular economy? Again, Industry 4.0 kind of data system, kind of industrial management, and circular economy and Industry 4.0, of course, they are fall under the scope of industrial management. So they are recent special issues, and if you are interested in submitted to this special issue, you can take a look on our website, contact the guest editor, etc. Okay, and see the scope of this special issue. Another statistic here is the impact factor since 1998. IMDS first obtained its impact factor since 1998. Initially, of course, is not very high. But I'm very glad to see that, if you can remember, I took up the editorialship in 2014. And since 2014, you can see a significant jump in terms of impact factor. Well, we didn't do anything like some of our competitor in the field. Our self-citation in impact, well, our impact factor without self-citation actually is very close to the impact factor, okay, of IMDS. We only have roughly like 10% of self-citation, and this also make ourselves very proud of it, because we don't rely on self-citation. And the total number of sites since 1998, of course, is increasing, and I am also glad to see an obvious jump since 2014. If you talk about citation, of course, we want to understand what kind of journals cite IMDS. Well, basically half of them, more than half of them are business-related journal, and another, say 1/3 are industrial engineering related, computer science, information engineering related, okay, and plus various domain, of course. And in terms of our authorship, we have analyzed this bibliometric some time ago. So you can see roughly a quarter of our authors come from North America, another quarter roughly come from Europe, okay, and another quarter come from Asia, particularly different regions in China, okay, and others countries. So we have quite a wide spread of authorship over the world. Okay, we don't rely only on, for example, one particular country, okay, in terms of our submission. And the same bibliometric analysis also tell you, some hints about the topic we are interested in. For example, in cluster 2, you can see supply chain management, which is quite obvious, all right? And in cluster 1, we have lots of information system related topics. Well, of course, I'm not going to discuss each of this topic, but you can see, roughly what we would like to publish in IMDS. So basically, that's all I would like to share. And thank you very much for your attention. Your questions are welcome.
Okay, right. Thank you so much, Professor Chen, for the nice talk. Through different perspectives, and combining the 3D printing, blockchain, and some cutting edge and technologies, and also sharing as an editor-in-chief or co-editor-in-chief in IMDS. So ladies and gentlemen, if you have any questions, please using the Q&A channel or the chat channel. Okay, so I will invite Professor Chen to answer your questions. We got one question from Q&A. is from one of my PhD students. Thank you so much, Professor Hing Chen, for sharing. This is Wen Nang from IMSC. The 3DP is prevalent in digital twin technology. I wonder what challenges should be focused on if we want to combine this technology, digital watermarking technology and blockchain technology with digital twins. Hope to get some advice from you. Thank you.
Well, all right. I think this question is quite broad in nature because it also depends on what kind of application from the digital twin. Like in manufacturing software, we can use digital twin like for maintenance, for example. So we don't need to disassemble any equipment, and we can get sensory data from machinery. So we can create a digital twin, okay, to monitor the status of the machine, equipments, etc. And for those applications, actually, I doubt we really need watermarking technology, right? Because this is in-house usage. But if you are talking about digital twin application out of this context, especially if it's involved customer and customer, then I believe a similar concept can be applied, okay? Because at the end, when you go to digital twin, you do something virtually and you will get back to the physical world, right? And anything happen in the digital twin could be proprietary in nature because you may need simulation to analyze certain situation, and then you may come up with certain, for example, product design, right? And when we come back to the physical world, of course, you need to protect the IP of that digital version. And if there is any leakage of this digital twin version to the outside world, that means some other company, you know, can make use of the design to do manufacturing and sell the product. So similar concept can be applied. But that comes to another question, whether the output is digital in nature or not. When you go back to the physical world, the product can still be digital in nature, right? So you can use a dynamic watermarking approach, okay, to add to the digital content, just like the YouTube example I mentioned. But if the output is physical in nature, again, you know, a similar technique here. Of course, you don't necessarily use the watermark technology with pattern for it because it's tailored to 3D printing objects. But you can use a similar watermarking technology or approach to add watermark onto the physical product, and then you can protect the product in this way. So, you know, that's why I mentioned that this is a very broad question, okay? But broadly speaking, you know, if we divide this into different type of category, different application, this is my response to this.
Mm-hmm.
Yeah.
Okay, right. Thank you, Professor Chen. Another question is from Ziqing Ni. So he or she hasn't mentioned about the affiliation. Maybe Ziqing, you can tell where you are studying or working on. Okay. So the question is why there is a significant increase of the rejection rate in 2021 compared with 2022 of the general MDS.
Well, actually, Jixing is my is from I know Jixing. He is my part-time PhD student. Okay, he's from Xian Liverpool. I think this is the same Jixing. Well, you can see here the acceptance rate. That means the rejection rate drop from 2020 to 2021. I mentioned because the number of paper published has been increased in 2020. So the reason the real observation should be on 2019 to 2020, there's an increase in acceptance rate because we increased the number of paper published. So that means indirectly the acceptance rate increase, and then we control, of course, the acceptance based on the submission. You know, this is kind of mathematics. So number of paper we receive, number of paper we accept at the end, that determine the acceptance rate. So we publish more. So from 2019 to 2020, we have an increase in acceptance rate. And when we come to 2020 to 2021, we need to control, okay, back the acceptance rate, and we attract more submission. This is the way we do it. The reason we want to increase the number of paper published is because of the number of paper we have attracted, and we see the trend. So even if we didn't do anything, we would expect the increase in number of submission, okay? And that is a consequence of our promotional work, how we promote the journal, etc. That's, well, is the outcome, okay, of this.
Okay, right. The Zhiqing is from Xi'an Jiao Tong Liverpool
Yep.
University. It is exactly what Professor Chen mentioned.
Yeah.
Okay, thank you, Zhiqing. Next question, also from our department. Good evening, Professor Chen. Thanks for your great presentation. I'm Annie. So the question is, I would like to ask, would a topic about data-driven sensitivity analysis for construction industry be considered in your journal, IMDS? Thank you.
Okay. Our journal, well, to answer this question, let me talk about the industry first. Our journal is independent from any industry. So we accept papers from various industry. So construction industry is definitely possible, but you need to address the scope of IMDS. That means that we are treating the interface between operation management and information system. So data-driven kind of thing probably will address data system part. I'm not sure whether a sensitivity analysis is, well, something related to operation management or industrial management. So because sensitivity analysis doesn't mean industrial management, but if you are talking about some sensitivity analysis in terms of the operation, project management, etc., then that would be okay.
Mm-hmm. Okay. Thank you for the answering this question. And may I ask 2 questions?
Oh yes, of course.
Yeah, I write 2 questions along your presentation. And thank you so much, Professor Chen. A very wonderful talk. The first question is about the platform and authentication platform. Any special requirements of the hardware, for example, the computer or server that can run the 3D model? Sometimes, you know, the 3D model may be very huge. When loading and uploading the 3D digital files, sometimes it costs a lot. I mean, the computational cost.
Yeah. Well, if you just talk about the encryption, decryption, well, it can be done very easily based using some computer, okay, off the shelf computer. We don't have tight requirement on it. But when you talk about if it is commercialized, when we put this platform in industry, in practice, of course, there are lots of consideration, like, you know, number of users, etc. So that is related to that. Okay, I would not be able to address to this. But if you just talk about the basic operation, there's no tight requirement on the computation power, etc.
Mm-hmm. Okay, and another question is the mobile smartphone version. So your platform is a desktop based version, right?
Yeah.
Yeah. If I'm correct. So for the mobile phone apps, for example, the end users may have a look at the 3D model, but the capacity of the smartphone will be like less than the desktop. Any possible to convert the 3D model into a lightweight so that this model in the apps could be combined seamlessly with the desktop version? Thank you.
Well, this is an interesting question. I would say yes, because if you're talking about just using the platform itself, you should have your CAD file, STL file ready already. If you don't, if your application does not relate to design, then that should be okay because it's more about uploading, downloading, etc. Encryption will be done, you know, in the cloud, off the scene, right? But if you're talking about design, the 3D file, etc., well, of course, that is not possible at this stage, I would say. Yeah, depends on which state you're talking about. But back to your first question. Well, actually, I also forgot about the scanning part. So if you want to scan the physical object, that means to extract the watermark embedded in the physical item. Of course, that would be depending on how good your scanner is. The better the scanner, of course, it would require a better, you know, computing system to cope with it. And similarly, if you're talking about using mobile phones to scan the object, you know, the resolution may not be able to achieve a good scanning. Okay, and these two are relevant as well.
Okay, thank you so much for the answering.
Yep.
Actually, I make some notes. I learned a lot. Thank you. Another question is from ESD. Yeah, and he or she hasn't mentioned about the affiliation as well. If you are there, please type your affiliation so everybody can know. The question is, thank you for sharing. Although blockchain has advantages of a temporal proof, there are many traditional industry in China. The whole digitalization is not enough, so it should be used on a large scale in the industry. Is industry digitalization a prerequisite for blockchain? What are the biggest obstacles to the large-scale application of blockchain technology in the industry? Thank you.
Well, this question actually helped me to answer why we want to develop such a platform. Because this is also the question we thought about. Remember in the phase 1 study, we found that actually the penetration of 3D printing is not sufficient. And this is currently related to digitalization. Okay? Although our focus is 3D printing, but generally speaking, digital manufacturing, digitalization, actually, the penetration, the adoption, the usage actually is also very low. And one reason behind the development of this platform is that we can make use of this platform, open it to the industry. So manufacturers, they don't really need to invest for this patent technology, and then they can protect their IP via the system. As I mentioned before, commercialization, although the words we use in this context, this is the action, you know, we call commercialization, but we are not really focusing on setting up a company to earn profit from the system. We want to help the industry. So this is the ultimate objective. And if company can use the platform, you know, which is kind of an ecosystem, well, basically they can get benefits out of the platform. And you know, they don't need to, well, I would say they can minimize the investment on using this technology.
And also, yes, the mention about any obstacles for using the blockchain in the industry.
Oh, yes, of course. I believe the major obstacle it's the same in various industry. Okay, it's not just for 3D printing application. Well, first of all, blockchain is kind of buzzword to many companies. They don't really understand what blockchain is about. If we link it to cycle currency, of course, this is Bitcoin. This is the most famous application. But to us, like RFID, we need to deploy RFID properly according to our lead. So first of all, we need to really understand the list of using the blockchain technology. And blockchain is just a security system, okay, to us. So in industrial engineering, when we integrate different type of technology, we need to focus on the application itself, whether or not the blockchain is the right technology to be used. So we need to, this is the major obstacle to me, apart from investment, apart from the cost of using it. So just like, as I mentioned earlier, 3D printing is quite a mature technology, but if we use 3D printing to substitute existing traditional manufacturing technology or process, basically it doesn't work, right? And blockchain technology the same. If you think that blockchain technology can be used to, well, protect everything, so again, it doesn't work. So this can I say misconception on blockchain probably is the biggest hurdle where we need to get it right. Okay, so in order to get it right, basically we need to understand what blockchain can offer, what are the advantages of blockchain and how we can apply it in our context. So basically this is the biggest issue. And rather than, you know, blindly use blockchain in all our application.
Mm-hmm.
And of course, investment always an issue, but I mean, it's not a special optical. I think the question is not looking for investment type of answer, right?
Mm-hmm. Yeah. Okay. Thank you so much, Professor Chen. So we still have a few minutes for take the last one question. Any from the panel members and the participants?
Yeah, Professor Chen, may I ask you a question? I think you spent a long time in Hong Kong. Do you see, like in Hong Kong, what do you see about the opportunities, let's say for 3D printing and also blockchain? Yeah.
Well, if I look at the 3D printing part first, okay, we all know the labor-intensive manufacturing process have been moving away from Hong Kong, right? In the past 50 years ago, say Hong Kong was very manufacturing intensive. And one reason of this shift is, of course, about labor costs. And 3D printing actually provide us with an additional advantage. I mentioned it in my presentation, which is mass customization. So the process is quite relatively automated and related to less labor content. And this fits actually the situation in Hong Kong very well. But the problem is that we need to make good use of the 3D printing characteristic, okay, in our application. And again, you know, if we just think about, you know, mass production type of manufacturing process and then apply 3D printing to it, basically it doesn't work again. So we need to extract the customization part of the 3D printing technology. Then that would be quite useful to Hong Kong company, or, you know, at least technical company. And on the blockchain side, basically, again, is a security system to me. And of course, we can apply it in Hong Kong, and especially Hong Kong is a financial a center, okay, still a financial center. So the technology itself can help us to protect a lot of financial transaction in that regard. But we're, you know, in this regard, we also move away from the manufacturing industry. And in the manufacturing industry, of course, again, you know, I have addressed this question already. We need to match the characteristic of the blockchain technology to our application, okay? And of course, there are lots of opportunities, okay, to Hong Kong companies.
Thank you, Professor Chen.
Yeah.
Okay, right. Thank you so much. And I should ask the last question, and I promise this will be the last on behalf of the Alliance. Because we have the supply chain, the Logistic and the Supply Chains Innovation Alliance in the Great Bay Area. I know Professor Chen actually did a large number of research and achieved fruitful outcome in the logistics and the supply chain management. So could you please give us some, insights or suggestions for the logistics and the supply chain in the Great Bay Area specifically?
Okay, so it doesn't related to the presentation. Today,
Yes.
right, at all. And another branch or another direction of my research is about multimodal logistic network design. Okay, I just finished a project in this regard, especially in these few years, digitalization is forced, okay, to become a reality. And many companies, they need to adopt digitalization or digital strategy. And this also facilitates multimodal transportation. And well, I must admit that I may not be very familiar with the multimodal transportation network development in the Great Bay Area, but at least in our area here, multimodal transportation network design is still a very important topic here. So probably the same can apply to the Great Bay Area.
Mm-hmm.
In terms of multimodal transportation, this can link different transportation mode, and the design itself could involve traditional logistic and warehousing management, like the number of distribution center in different areas, the mode of transportation, etc. And that will become a multi-objective optimization problem, like in my previous project. And we are also expanding this project to cover more location, okay, globally. And in the past, in my previous project, basically we focus mainly on the Ningbo, Shanghai area. But in fact, similar multimodal transportation network design can be applied to, well, basically everywhere. So I think this is also a potential research area, okay, in this particular area as well.
Okay, right. Thank you so much, Professor Chen.